This presentation is part of the TI-Nfocus AP Calculus video series. In this video, I'll discuss the scoring guidelines for the 2019 AP Calculus exam, free response question AB5. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I'm a former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading in Kansas City. I'll present a brief general summary for student performance on this question, and then I'll consider more detailed interpretations of the scoring guidelines and how these guidelines were applied in certain situations. I'll consider some common student errors where it's relevant, and where it's appropriate, I'll present some specific scoring examples. This question involved a region R bounded by the graphs of y equal g of x, y equal h of x, the y-axis, and the line x equal 2. In Part A, we need to find the area of the region R, that is the area of the shaded region in the figure. In Part B, the region R is assumed to be the base of a solid. At each x, the cross-section perpendicular to the x-axis has area given by the function a, and we need to find the volume of the solid. And in Part C, we need to write an integral expression that gives the volume of the solid generated when the region R is rotated about the horizontal line y equals 6. Part A was worth 4 points. The first point was for writing the correct integrand in the context of an integral. The second point was for the antiderivative of the term involving the cosine function. The third point was for the antiderivative of the remaining terms. And the fourth point was for the final answer. Part B was worth 2 points. The first point was for the integral, and the second point was for the answer. And Part C was worth 3 points. The first point was for using the correct limits, x equals 0 and x equals 2, and the correct constant, pi. The second point was for the general correct form of the integrand. This was sort of a conceptual point. And the third point was for the correct integrand. Here are some general comments about student performance on this question. In Part A, most students understood the necessary concept to solve this problem, a definite integral of h minus g or g minus h. But unfortunately, there were some algebra and arithmetic errors. Some students had trouble finding the antiderivative of a composite function, specifically 3 times the cosine of kx. That is, where the argument was a constant times x. There were some copy errors, errors in identifying the curve on the top boundary and the curve on the bottom boundary, and in expanding the quadratic. Some students also reversed the integrand here, and they arrived at a negative area, but they did not resolve this issue. In Part B, some students did not know how to use the function a. It seemed like some students were trying to construct a function for cross-sectional area involving a. Some students included an incorrect constant multiple, and common errors were including pi or 44/3 from Part A. And some students simply presented incorrect integrands, and here are 2 common errors. In Part C, some students omitted the constant pi, or if they presented pi in the integrand, they made a presentation error, often involving parentheses. Some students did not use y equals 6 as the axis of revolution. For example, some used y equals 2 or y equals 7, and I'm not sure why. Some students presented functions of the variable y in the integrand. And there were some general presentation errors if explicit expressions were used, instead of the function names g of x and h of x. Now, most of these errors involve parentheses, which made the integral ambiguous. Here are just a few general comments about scoring this question. The functions g and h are defined in the problem, so students can, and should in my opinion, use g of x and h of x where appropriate, instead of trying to write out the expressions for each. That often leads to copy errors or parentheses errors. And the same for the function a. It's defined in part b, so students should use a of x where appropriate. In this problem, this year, if it was unambiguous, then the cosine of pi over 2x without the parentheses was read as if the argument was pi over 2 times x. A missing dx in the integrand was not penalized. Now, this isn't the case in my class, but under the pressure of a high-stakes exam, it was allowed this year. Bald answers do not earn points. That is, answers without any supporting work where some is expected. And there were some common simplified expressions for these differences that students presented, and that was okay. Now, let's look more carefully at the scoring guidelines. And just a reminder, this was not a calculator active question. First, here are a few general comments about scoring Part A. Bald answers or bald integrands earn no points. For example, if the student presented just the answer 44 over 3, or just the difference h of x minus g of x, they did not earn any points. The limits of integration are considered part of the fourth point, the answer point. And there was one special case in which some students integrated from x equal 1 to x equal 2. And I just want you to know that we had a fair way to score this solution. The first point in Part A was for the correct integrand, and this point was earned for writing h of x minus g of x, or g of x minus h of x in the context of integration. Remember that a reversal in the integrand earns the first point, but it must be resolved to earn the answer point. If the student made a copy error consisting of a missing or incorrect constant, they are not eligible for the fourth point, and the only allowable copy error in the cosine term is a missing 3. If the student made any simplification or arithmetic errors after earning the integrand point, they are still eligible for the second and the third point, but not the fourth. Here are a few more notes about the first point. If the student presents h of x plus g of x as the integrand, they are only eligible for the second and third points, the antiderivative points. And if the student includes other functions in the integrand other than h of x and g of x, for example h of x squared, then they earn 0 out of the 4 points in Part A. The second point in Part A was for the antiderivative of 3 times the cosine of pi over 2x. If there was no copy error, then the point is simply earned for the correct antiderivative. The only copy error we will read with is a missing 3 out in front of the cosine. But in this case, the student is not eligible for the fourth point. Now, if a student chooses to use u substitution, then they must explicitly state that u is equal to pi over 2 times x. The third point in Part A was for the antiderivative of the remaining terms, and we simply read for the antiderivative of all the remaining terms. And once again, if the student uses u substitution, then we must explicitly see that u is equal to x minus 1, and here we also need to see the antiderivative 1/3 u cubed. The fourth point in Part A is for the answer, and there was an eligibility criteria here. The student must have earned the first point for the integrand. They must have earned one of the second or the third points, the antiderivative points, and they must have no copy errors, no simplification errors, or no arithmetic errors in the integrand. There were two special cases in Part A, and the first one involved responses in which no integral symbol appeared. It was possible for the student to convey the integrand, the antiderivative, and the evaluation without actually writing an integral symbol. Now, I don't recommend this notation light approach, but in this case, the student was eligible for all 4 points. And some responses did not include an explicit antiderivative of 3 times the cosine of pi over 2x. In this case, we need to see the antiderivative of all the remaining terms. And if the student is eligible for the 4th point, they must report our answer. Part B was worth 2 points, and the first point was for the integral. It's pretty straightforward. We need to see the integrand as a of x, and we need to see the limits, x equals 0 and x equals 2. The second point was for the answer, and simply, it has to be correct to earn the point. Here are a few extra notes. Students were not penalized for a missing dx in this part. A bald answer did not earn any points. The limits may appear late. That is, a student may find an antiderivative of a of x and then use the limits. Once the integral point is earned, it's banked. However, if the student redefines a, then they don't bank this point, they don't earn this point. And here's an example. Here are some examples of student responses in Part B and how each was scored. Example 1 is a bald answer. If the student simply presents the log of 5 minus the log of 3, or just the log of 5/3, there is no supporting work. This earns 0, 0. In example 2, both of these integrals are missing the bounds, so either of these responses earns 0, 0. In example 3, the integral setup is incomplete, but the student has the correct final answer, so this earns 0, 1. In example 4, the student uses U substitution, but the bounds on the definite integral are wrong. This is a presentation error. They did, however, determine the correct final answer, so this earns 0, 1. And example 5 is pretty minimal, but the presentation is correct, and the final answer is also correct. So this earns 1, 1. Here are a few more example responses and how each was scored. In example 1, if the student includes an additional constant multiple, this earns the first point but is not eligible for the second. Example 2 is similar. However, here the student has included an additional constant in a sum or difference. This also earns 1, 0. Example 3 is one step more than a bald answer, but not quite enough to earn any points. But in example 4, the student has conveyed enough with proper notation to earn both points. Part C was worth 3 points. The first point was for the limits and constant associated with the definite integral. To earn this point, the limits and constant must be presented in the context of a definite integral. There must be an integrand, correct or incorrect. So a bald answer here is an integral symbol with limits and constant, but without an integrand. And simply, the limits must be correct and the constant pi must be correct. If there are any constants added or subtracted to the integral, then the point is not earned, and here's a common error. Some students wrote the constant pi inside the integral symbol, which is okay, but those students were prone to presentation errors, and most of these involved extra or missing parentheses. The second point in Part C was for the form of the integrand, and this was kind of a conceptual point. The only acceptable form was the difference of squares with a correct or consistent axis of rotation. And here are some forms that earned the point that involved the expected integrand. And here are some forms that also earned the point, that involved the expected integrand multiplied by -1. Now, if one term is completely correct and the other has a single missing parenthesis, then the second point is earned, but the student is not eligible for the third point. There were a couple of special cases in Part C. Some students explicitly used a 6+ and a 6-, and here are a couple of examples. This earns the second point but is not eligible for the third. And some students were actually able to start this problem with a simplified integrand. The simplification must be correct, or multiplied by a -1, to earn this second point. And these are the two common simplified expressions. And finally, the third point in Part C was for the integrand, and that means the correct integrand. A reversal here does not earn the point. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. There is also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.